Hi, everybody. My name is Dmitrii, and surprise, I will talk about core data and our experience with this framework. I will give you some example what can happen when people start implementing core data, thinking that it's really easier than it is. What can happen in this case? So I will start with describing a bit our app. Then we will discuss some common core data issues that we faced. Then I will tell you about our struggle with the framework and with ourselves, mostly with ourselves, I think. Then in the middle of the struggle, we will have a break and talk a bit about some important questions which everybody has to ask themselves before implementing core data in the project. We spent some time comparing some core data stacks, and eventually I will tell you about our outputs from this journey. So first of all, Qardio. I work at a company called Qardio. The company develops, produces, and sells their healthcare devices: blood pressure monitor, smart scale, ECG monitor. All the devices stream data right to the mobile app. Mobile app processes the data, locally store it, displays it, and synchronize the data to the rest of the system. And data synchronization plays quite a big role in the entire Qardio infrastructure. And core data is the keystone of iOS part of synchronization. So let's take a look what requirements do we have in our persistence layer. First of all, everything should work offline. The user should be able to store data, see already stored data, and as soon as internet connection is established, everything should be synchronized to the backend. We get most of our data from our Bluetooth devices. We have bidirectional exchange with our backend, and sometimes it can be really heavy and go in both directions simultaneously. Then we have exchange with HealthKit, and now overall we have about 40 core data entities like profile, settings, measurements, devices, reminders, a lot of stuff. And so far it's about 50 sequential core database models in the model versions. Sorry. The issues. Which issues did we face? First of all, multi-threading violation. Hey, number one issue. Sorry?
I said that's really new.
Yeah. Well, if you...
iOS 5, so it shouldn't be a problem.
It's a problem because of developers, not because of some limitation of the framework. If you use NS managed object out of the context, you're in trouble because nobody can guarantee you the behavior. Sometimes it can work, sometimes it can behave weirdly, sometimes it can just crash. For instance, this piece of code is an example of such violation because we instantiate the core data model known core device in the worker context, but then we access its property serial number in the whichever thread calls this method. So it's not safe, and it can cause big variety of problems. For instance, it can cause something like this. It's a crash message when you access some core data model property from the different threads simultaneously. So it's just simultaneous access. In this case, access to the collection. It can also throw you something like this if you try to access the property of core data model, which is reference to another core data model itself. So it's a fault which cannot be fulfilled from the wrong context. That is multi-threading violation. The next one, context merge issues. So these issues happened when after some merging between different contexts, we lost some data because data wasn't saved, or it was saved but instantly overwritten by some other changes from different contexts. We also have plenty of UI issues because sometimes there were just too much stuff going on in the main thread. Sometimes the logic of multi-threading logic was too complex that UI blocked itself. We had version and migration issues. Well, in most cases, it's an easy situation when you just forget about the migration and core data crashes on app launching. But we also had some interesting cases, like imagine that you have some database structure. Let's say it's version number 3. Then you make some changes and decide to keep the same version number. Why not? Core data can handle it. So you have two. Yeah, you can do it. After that, you have two versions of version 3 in production. Let's call them 3A and 3B. And at some point, you decide to make version number 4. And here, in version 4, the changes are more significant, and you write some custom migration. And it perfectly works from version 3B and doesn't work at all from version 3A because in fact, it's different versions, but core data cannot distinguish them because they have the same number 3. Yeah, and of course, we had plenty of other crashes. Something like this. You can get that something is wrong with core data, but in some cases you cannot get what specifically is wrong and even which place crashes. Yeah, so how did the team struggle with all these issues? Some of them, like version and migration, were quite easy. So you just need to read the documentation because it's quite extensive on this specific matter. Understand it, and you're ready to go. We figure out this simple set of rules. First of all, you have to start with versioning from the beginning. So the first release build that you have for your app with core data inside should have some first core data version. You will appreciate it later. You have to create new version every time when you do some changes to your core data structure. And you shouldn't forget about migration from the previous versions. And I'm talking not about the recent one, but the ones before the recent one. Sometimes it's necessary. But not all the issues were as simple as versioning and migration things. And sometimes, after struggling, developers resorted to the last dirty solution, synchronizing everything through the main context. With such simple mutation of the code, some issues were suppressed, and it looked like they're fixed, but they're not. So more and more code was moved from the background to the main thread, and a lot of stuff was going on in the main thread, and some elements of business logic, which originally supposed to be thread independent, started to have such checks inside. So you think it should work from every thread, but no, it's not. And you're lucky if there is an assert which will crash the app when you call it from the background. Sometimes there is no assert. It just behaves weirdly. And in the Git history, I even found this. This masterpiece of coding when somebody decided just to cancel the background processing and dispatch everything to the main thread. Why? Why not? So, of course, the team couldn't get away with this approach, and eventually UI became worse and worse, and it was decided to move logic back from UI to the background, and of course all the issues which were suppressed were back again. So we were running in circles. At this point, the ingenious conclusion was made. We just need to change to a new stack. It's supposed to solve all our problems. At this point, I will pause for a while a Qardio story and talk about briefly about core data in general. So here are some questions which I think everybody should ask themselves before implementing core data in the project. Some of them are really easy, some of them are quite controversial and don't have one single right answer. But if you don't discuss it in advance, you can be in troubles like we were. So let's come through some of these questions. First of all, the easiest one. What is core data? Everybody knows. It's not ORM, it's not SQLite wrapper, it's an object graph which is supposed to be persisted on disk. Can be persisted, but not necessarily. And this is actually important nuance because core data is supposed to be not only the persistent layer between app launches, but also the entire model layer in runtime. And only understanding that, you can answer the next question. Do I actually need core data in my project? And the answer is not necessarily. Because if you just need to store the data between launches and you don't need any of these core data essentials, just don't waste your time. And go for some options like real SQLite wrappers or some other ways of storing data. Yeah. So if we decide to put core data in our project, we have to be ready that it's going to be deeply integrated, but there is still a question, how deeply should it be integrated? And to answer this one, let's go to this scale. So it's kind of an abstraction scale, and on one end of the scale we have deep integration of the framework, and in another end we have complete abstraction. What do I mean? If we have deep integration, we instantiate models somewhere deep in our data layer and pass them throughout the entire app without any changes, without modifications, without mapping or parsing. That's an example how core data can make an entire model layer of your application. Which benefits it gives us? First of all, it's easy, no extra code. We use core data models as they are. Then if we pass the models around the app, we can leverage all the core data benefits everywhere. It's nice. And actually, it's how it's designed to be used by Apple and inspired. Yeah. On another end, we have complete abstraction, which means that we cover core data with some protocol or facade. We map all the models to the plain structures and back, and actually we use core data as an SQLite wrapper, nothing more. And that's not good, as we already discussed, and we won't consider this approach. Instead of this, we can think about some relative abstraction. So for some models, in some business units, we do have the border, which core data objects are not supposed to cross. Here we map core data models to the plain objects and pass them further. There is an opinion that this way we can make our architecture cleaner because we have looser coupling. We have some pieces of our logic which are completely abstracted from core data. And because of this, these pieces of logic don't have this multi-threading overhead. So if we pass just plain models, we don't care about threads and context anymore. With this approach, we have less temptation to access SQLite or coordinator directly. So it's also nice for some people. Yeah, now let's talk about core data stacks. And before deciding which stack to choose, let's briefly brush up what is core data stack. And core data stack is context, coordinator, and store, and the connections between these objects. So if you pick one instance of each class, we can have the simple stack, simple, fast, but completely useless for production app because we don't have any background processing here. And for extend our stack with background context, we have basically two options. One is sequential chaining the context, and another one is connecting them in parallel. Let's start from sequential chaining and as so-called nesting context. We can skip some models, and let's talk about this one because it's completely production ready. A lot of people use it. Here we have separate background workers which are connected to the main main context. By disposable workers, I mean that they can be created per tasks and can be destroyed right after the task is finished. all the changes are merged to main context, so we don't need to write any special code for this merge. And we have a separate private context, which only role is just to make input-output operations to the store to move this logic from the main thread. But with all these context layers, we have to write some code for pushing changes from context more than one level down, because by default we can push only changes from the child context to the parent. We cannot avoid passing all the changes from, for instance, worker contexts through the main thread, because we have no other connection between workers and the store. So every time we store some data or we fetch some data from the store, we have to pass everything through main context. And for some high-load operation, it can have a huge impact on UI. It can be visible. UI just starts freezing from time to time. And we don't have merge policy on the context level. So if we have some conflicts between child context and the parent context, everything is merged only with the priority of a child context. No options here. Let's move to some parallel connections. Here is the classic example of shared coordinator model. We have two or even more independent contexts sharing the same coordinator. Because of contexts are independent, they don't influence each other much. So if we have some background processing, some storing data all the time from the background to the store, it still doesn't influence on the main context. That's great. Here we can use common raw cache. Raw cache is the caching layer inside coordinator. So if we use the same data in both contexts, we don't have to make the round trip to the store. We have adjustable merge policies on coordinator level, and we have flexible merge of the context. The merge here is done via notification, so we are free to pick which contexts we want to listen and which ones we can ignore. We can pick out of the entire set of changes which one we have to merge to our context, and again, which we can ignore. And all this, flexible merge comes at a price that we have to write this code, and it's one of the disadvantages of this stack, the code to merge changes between stacks. Merge is not instant because we rely on notifications and they are asynchronous, so we have a time gap between the moment when the changes are done in the store and we process them in the context. Because of this gap, we have to think about some policy when dealing with objects which can be deleted from the store by another context. And yeah, here's the next one, shared store. If we will parallel our stack even more, we will get to this model. Obviously, we have even more independent context, even less impact from one context to another. This stack is also very convenient when you want to use the same storage for different locations, like the app and the app extension, or different bundles inside the app. So basically, you have different storages, different stacks, backed with the same SQLite storage if you use SQLite as the backend storage. And of course, all the disadvantages of this model comes from this independency. We don't have common raw cache. All the merging now is done on the store level and not in memory, as it was in the previous models. And we cannot use object ID because object ID is related to specific coordinator. And here we have URI representation, which is kind of the replacement of object ID in the store level. But for passing a reference on an object between contexts, now we have to get object ID first, then translate it to URI representation, pass the representation, and make all these operations the other way around to retrieve an actual object. Okay, the last one, mixed stack. It's a real mixture of nested context and shared store models. It has all the benefits we discussed, but it's really complex. It's complex to set it up, it's complex to tune it. But these disadvantages can be covered by some third-party libraries. There are some open source solutions for that, and that's good. But I would say that additional complexity is using this stack, because there are several different contexts and you have to clearly understand which context is used for which kind of operations. Because if you mess things up here, you again can be in trouble. Okay, I did some comparison between these models. Here you can see the models and well, I tried to extract some features from the stacks, yeah, and I try to compare the models feature-wise. So if you see the red square, it means that this model is the worst comparing to the others in this feature, and green square means it's the best, and yellow something in the middle. We can see that more or less NS persistent container is pretty much a good option. It doesn't have any red squares, and yellow are not so significant. Maybe just delay when syncing the context, which I told about. And we have mixed context, which is all green, but the complexity can be quite a significant disadvantage. To get the difference even better, I made some benchmarks. Here, well, we have NS persistent container and shared coordinator, which are basically the same model. I just wanted to compare them between each other, and you can see that the results are more or less the same. So let's forget about shared coordinator and pick NS persistent container as a representative of this model. So first experiment was inserting data from the background thread. And here the results are quite predictable. The best models are shared store or shared coordinator / NS persistent container, because they have the most independent context. Everything is clear. Talking about fetching data from the main thread, well, they are all equal, no surprises. But the interesting thing started when we do fetching from the main thread and insertion from the background thread simultaneously. Here we can finally see the difference between NS persistent container and a shared store model. So we can finally well, see that SQLite locks are faster than the locks, the lock in coordinator level. But the winner is nested context, because it doesn't really has any real concurrency, it doesn't have any locks, and all this stuff is merged within main context. That's why, although it has some not the best result in the pure insertion in the mixed condition, it works quite nice. Okay, how to choose the stack? First of all, pick the least complex one which fit your needs. That's really important. Don't overcomplicate things for yourself. Then you have to carefully consider which use cases and data flows do you have in your application, and prioritize them, because well, picking a stack, it's about trade-offs. I would say that NS persistent container is the best option in most cases, but sometimes you do need some extra things, and if you have a lot of high-load operations which can be synchronized to the main thread, not simultaneously, you can pick a shared store model for that. If you do need to synchronize the background stuff to the main thread instantly all the time, nested context is your option. And of course, if you have everything on your plate, pick the mixed contexts and learn how to properly work with it. So let's get back to our struggle. We paused at the point when we decided to switch stacks, and we picked mixed stacks because we really do have a lot of different use cases and we do really need it. We found a lightweight open source solution from the Big Nerd Range guys. Nice small library, well documented, encapsulates all this creation of the stack, all these connections between different contexts, useful things. Together with this, the switch itself, we had to review some code, of course. And well, we started to see that the situation is getting better. Some issues were solved, other were not so bad. after that, but we still had enough of them. And we started to notice that new issues appeared even after the big migration. So maybe the stack is not the root of all evils. Maybe the reason is in something else. And yes, we still didn't understand. We, as developers, didn't understand core data completely. We still have some flaws in our understanding. We didn't have the whole comprehension of the framework, and every here and there we did some mistakes in our code. And we started to work on that. We read articles and books. What else could we do? We shared knowledge inside the team. We did some discussions about core data issues and how we're going to develop the project core data-wise. Also, we decided to abstract some models from core data. For instance, we have user profile, which is widely used inside the app. Everywhere you need user profile. Not only to access its properties, but also to do some core data storing and retrieving, because the other entities are tightly connected to the profile. So we picked this one and created the plain structure and mapped all the profile data to the structure, and then passed the structure further, as I described before. I cannot, I'm not saying that it's good idea for all the core data models. Of course not. For most of them, it's better to leave them as they are. Yeah, but in some specific cases, when you widely use the object but you seldomly change it, so you don't don't leverage from core data benefits much, it might be a good idea because you get threat independency as a result of this change. And of course, we spent a lot of time killing all these multi-threading violation cases. So this piece of code should be converted to this one. With this small change, we can now be sure that everything works as expected. Luckily, Xcode can help you with that. And if you switch on this flag in your project settings, your project will crash every time when you access NS managed object from their own thread with such a nice message. So if you're familiar with this crash, you'll actually know what's happening, and it's easy to fix it. Our rules. Which rules have we developed during all these years? First of all, you should understand your edge of framework abstraction. In our case, we don't have some strict edge, but we do have a clear understanding of which objects can be abstracted from core data and which shouldn't be abstracted at all. Coming back to this scale, we started from the deep integration and moved towards right side a bit. Then, don't access NS managed object out of proper context. You should always remember that even though NS managed object is inherits from NS object, you cannot use it as a plain object. So Barbara Liskov's principle doesn't work here because of all this threat limitation and faulting. And so you have to choose whether you map core data models into plain objects and forget about all these complications, or you use managed objects as they are and keep in mind all these restrictions. Remember about version and migration, especially when you do releases to production. Some stack-related rules, easy ones. First of all, use main context only for UI-related operations, because you have to keep it as clean as possible. Regarding background operations, use general workers, the ones which connected to the main context, only for operations when you can guarantee a single access to the data store, or when you do really need some instant synchronization between this between the workers and the main context. And all the rest should go to the batch workers. So I cannot say that we are done with these changes. We're still on our way, but the results are really fascinating for us. We eliminated a lot of problems at all. multi-threading violation is still there because we still have some pieces of the code which we just haven't came across to. So every time when we find a new one, we kill it right at the spot. And we dramatically decreased our crash rate. Only core data related crashes, we had about several dozens crashes per day. And now it's one crash each 2-3 days, considering that user base increased 8 times for last 3 years. So I think it's a good result. Which conclusions can we make out of all this talk? Not a short one. First of all, core data can bring you much pain if you don't use it properly. If you use a hammer without proper skills, you can bruise some fingers. So you need to dig deeper into the framework, you need to read books, articles, you have to practice with some sample apps before implementing it in the real production application. Don't forget to share knowledge inside the team. It's a general advice, of course, but in core data it's super important because of all these issues and, well, it's a real complex thing. You may know a lot of stuff, but there is still some flaws in your understanding. Stack is not a silver bullet, but it's really quite important to pick the proper one for your project. You have to figure out some rules and principles and write them down so everybody can understand how to write new core data code. And you have to enforce these rules and principles every possible way with words of explanation, with brute compulsion if you need, with some tools from your IDE or CI. That's actually it. Thanks for listening. Questions?
To give a bit of context,
Hmm?
to give some context on like how old and big is the project, how large is the team, and basically another question: have you considered other technologies or systems?
Well, the
Like
project.
thinking, right?
Okay, I got it. Thanks. So the question is about how old the project, how big the team, and all the context. The project is old. I think now it's about 6 years old, and of course it was started by some other people, some outsourcers actually. And core data was a part of the project from almost very beginning. So when the question about persistency appeared, core data was the first choice, and I think it was just randomly picked because okay, we have iOS app, why don't use core data? And from the code, from the Git history, I think people who implemented that from the beginning didn't understand much about core data. Yeah, well, the team is not big. The size of the team varied for last couple of years from 5 people to, well, 2. Now it's 2 of us, but we are hiring. And yeah, so we didn't consider any alternatives. I mean, now I think I cannot say it's too late to consider, but I think now after all this experience, I cannot say I'd like to change core data into something else because, well, I have some idea about Realm, for instance, and it's pretty much the same. It also has its contexts, well, Realms, and not all the same limitations, but well, some other limitations. So yeah, if we come across some silver bullet, in this case, some perfect framework for persisting the data and using it in runtime, maybe we can consider switching, but not now, not after all this, I think.
That would be also my question. Meaning, the more you, as you showed in the slides, the more you abstract, the more you lose, what makes core data.
Of course, the point is that you have to be really picky about what to abstract. So I try to explain that for some objects it can be a good idea if you don't use all these core data benefits. So if you have some object which you just instantiate once and don't change and use across the entire app, it's a good candidate for abstraction. But of course, if you need to leverage all this built-in optimization, you shouldn't abstract. That's why it's the tricky scale. I'm not sure where is the proper place in that scale, in the abstraction scale. I think it still should be closer to the deep integration, but I'm not sure how close.
Did you have any fetch-related performance issues?
What kind?
I sometimes work on an app that has, I don't know, 40,000 items in a data store, and on a somewhat complex fetch, you do notice that there is some delay there, but that also has to do with that I cannot straight up fetch it from the data store.
You mean fetching for the UI?
Yeah.
But when you fetch for the UI, you don't need a lot of objects at once.
Oh, you do.
I mean,
Trust me.
well, okay.
It's an app if there's one order with articles on the screen, and if you're on the
No,
right
we have measurements and you have a list of measurements that it can be hundreds of thousands of measurements, but you just don't fetch them at once, right? You have batch fetch, and well, we didn't come across any performance issues in this case.
Okay. Now, because I've been running into that a bit with core data, but that's because they have a core data model that is completely normalized. So, and that goes against one of the recommendations by Apple. That's the abstraction thing that you talked about.
Well,
I'm still searching for a way around that fetch performance.
yes, and actually normalization is also not so obvious because sometimes you'd better to add some additional fields if it helps you to fetch data quickly. Yeah, that's true.
One screen, I don't know, if you have the right screen, there's like usually there can be 10,000 objects related to that.
But again, you don't need them to need to display them.
You do need them all for calculation in this specific screen that I'm talking about.
Because if you, well, okay, maybe I just don't understand the case.
I'll show you the code.
Okay, yeah. I can say that give me 1 second. We came across some issue that we couldn't solve with core data. We needed to have a really big SQLite query with joining some tables and with aggregation and all this stuff. And we couldn't do it with all the core data built-in functionality, and we just use the raw SQLite request, but it's just one case around the entire app. Other than that, everything works. Okay. Yes?
Speaking about silver bullets,
Yeah.
so what's your justification behind using persistence at all in the application? So why don't you just send all the data to backend and let JSON fields deal with it?
Well, we do need persistency because of offline work. The app should work completely offline. So we duplicate all the data, well, not all the data, but some data in the...
Why is that? Why is this necessary for you?
Because, well, as our user, you're supposed to be able to use our Bluetooth devices even if you don't have an internet.
Well, I mean, I just try to understand because I mean,
Yeah, sure.
If you have a Bluetooth scale, for example,
Yeah.
You can fetch all the measurements. You can store the measurements until you have the internet, but maybe you don't need.
But we don't only store the measurements. We also, well, we have UI. You can see some analytics, some statistics, some charts of your measurements, and how can you implement it without?
Well, I mean, to me, it seems that this data can be fetched from back.
But what if you don't have an internet?
Then you don't have data.
Well, I started from that was one of our requirements. We cannot.
Yeah, I just try.
Yeah, we cannot move out of it.
First, if you're retrieving, I mean, if it's completely blind, you need to save it somewhere.
Well, I mean, if you get
Just go in there.
if you get data from your scale, so from Qardio, you can store this data, right, until you have internet.
How do you store that?
Well, this data you can store with core data with whatever else technology, but I mean.
But what if you have about 40 different entities which are related to each other and which you have?
But that's what I said. Why do you need all of these entities?
Because we have quite complicated app with a lot of screens and a lot of things.
I can name one use case, because where do you use this app? When you're in the fitness hall, right? How's your
We have, for instance,
fitness? It's usually completely
We
crashed.
have Qardio monitor which streams data, well, not 24/7, but you can stream it without any interruption for 2 days. And well, sometimes you don't have internet connection, and it's real-time streaming. So you receive like 200 measurements per second, and you have to store them. Well, it's not measurements; it's raw data, binary, but still, you have to store it. Yeah.
I developed a few tricks to avoid core data. I only use it when necessary. So one of the tricks is if you need to store, for example, the top 10 most popular searches, you don't need core data for that. It's the top 10, it's 10 items, 10 strings. Or if you
Sure.
need to store the user token, you don't need core data for that. You can use Keychain. So a lot of the times the connection is automatically made. I need storage, therefore core data. That's an invalid assumption.
But wait. If you use core data, it doesn't mean we don't use any other storage. We do use,
Yeah.
of course, Keychain. We store some binary data in raw files and just store a reference to these files and the core data.
The idea being that in parts of the app you can use other kinds of storage and you can avoid all the problems related to it. And you only use it when you really need it, when you need an object.
Yes, but one more time, core data is not only about storing between launches, it's also about model layer in runtime. With all the relations, with all the optimizations, when you need to fetch several thousands of data entities, data objects, sorry. Yep.
Are you using only one big model to contain all these 40,
Yeah.
50 entities?
Yes.
Have you tried separated in different
No.
containers and see how it goes and distribute the
Well, I think I don't understand why should we do that. I mean, we don't have any problems with specifically this one data model.
What is it that you're doing that you're using multiple managed object contexts as a worker?
What is the question?
In the picture you show, it's like two managed objects, which you say workers.
This ones.
Yes, with
Mhm.
one managed object context as a main.
Yeah.
So what is it that you're doing? Why do you need the workers?
Well, you need the workers for all the tasks which are not related to UI, actually. So, I don't know, some processing, so you fetching from the cloud, from the backend. So if you fetch some data, well, not much data, and you have to instantly display it in the main thread, you use these regular workers. If you just need, for instance, when as our user you install the app and you already have an account and you firstly launch the app, we do a lot of synchronization. We get thousands and hundreds of thousands measurements from the backend, and of course for this case we use batch context, which has a separate coordinator, because we used the workers before and it wasn't a good idea. These regular workers are for small tasks, or again, when you need to do something, you want to move it out of the main thread, but you still need to synchronize it back with with the UI, basically.
Because one of the advantages here is you have the main context, and you have like a child context on top of it. That's
Yeah, workers.
You can go into a screen, do all kinds of model changes, and then if you don't want to store them, you just forget about the context, and all your changes are cancelled. But what I don't understand about this picture,
it's actually the case when you have child context also related to the main queue for the UI. But again, if we want to get some small set of some small piece of data from the cloud, we don't necessarily need the separate batch worker. We can just download it, save it in the background storage. Save it in the background context, and again, if we need to use it simultaneously in the UI, okay. If we don't need, it's just easier to use it easier to work with this data in the regular workers because they are connected to main context, basically. Main context, kind of your source of truth, but not really.
what the DNR, the core data stack, says is that the main context, they actually call it the view context, and what they say is you should not do any changes on this view context. Any change that you do to the core data storage, you should do on either a background context or a child context.
There is some.
So not read only.
Yes.
Your context is used only for read-only on the main thread.
Yeah, but
And
the
you
funny-
use, for example, NSFetch result control, stuff like that,
Yeah.
to with that particular context.
I also really like this approach, but we don't use it here.
because the front
That
end
was
is
another question I was about to ask. If you have prefetching, because now, since iOS 10, you can use, for example, apart from all the stack that they are proposing, the one main context, which is the view context, and then you can create multiple child contexts as
Yeah.
for any background task that you may need, and then you have prefetching. You have you can use, for example, show a version of the data while you are refreshing.
Of course. They also
Kind of
introduced
things.
generations. I didn't talk about generation. It's also quite a nice stuff that
Because
they
with this you can
introduced.
solve a lot of UI issues as well.
Yeah.
That you might have in your application.
What I don't understand about this picture is that you have two persistent store coordinators.
Yeah.
How does that work then?
You can have multiple.
You can create.
Yeah.
So then you rely on the SQLite or your storage mechanism synchronization.
No, you could even switch. You can even use different stores.
Yeah,
Yeah. Well. What problem do you see with separate
what
coordinators?
What I usually do is that I have a single persistent store coordinator, and that all contexts are based on that one.
Well, the only difference with the shared coordinator model is that again stacks are more independent, and as I checked it with the benchmarks, you have some difference. It's not so big. I mean, the impact on the main thread, but you do have it if you use separate coordinators, because well, SQLite lock is faster than lock on the coordinator level, and in case of SQLite, you have several read operations, right, and one write operation. So you're much less likely to come across some blocking issues.
How do you diagnose threading issues with objects?
Which issues?
How do you diagnose threading issues that you use like a core data object on the wrong context or wrong thread, I should say? How do you find those?
With the nice flag in the Xcode project settings. It's actually a very useful thing.
You're using the fetch result control?
I think we still use it in a couple of screens, but not widely. Yeah, it's not, yeah.
Any suggestion to add the testing, automated testing for this setup?
Well, let's say it's not covered with tests in our project, but there are some approaches.
What we do
Yes.
is that we, if we do testing, then we have a memory-based storage.
Yeah. Well, that's one of the approaches.
And we populate the data store, because you usually need some data, right? We just populate that with our regular serialization mechanism that we already have in place for other areas of it. Because stuff that comes in from the network, we have to serialize that into deserialize it into the database. So we use that mechanism also to populate our test structure. So, but it requires a little bit of work.
Yeah, it does.
Once you get it, once you have it, it's like totally fine. You can very quickly iterate on your unit tests.
What is one feature of core data this project relies a lot? One feature specific of core data?
I think the most one we use is relations, because all these entities I mentioned, they are related to each other. And
Relations is basically any relational database. So I'm thinking something.
not so easily. Not so easily. I mean, for core data, well, you just need to do nothing. I mean, you just instantiate the object, and you can even traverse across the object graph without fetching. I mean, with just faulting. Well, not in all the cases, but in pretty much a lot of cases, you can just retrieve the relation from the faulting mechanism, and it would work.
So 14 is okay.
Faulting is also a great stuff again.
Yeah.
It also handles performance for you and all of that good stuff.
Hmm?
It also does handles performance
Yes.
for you, batch fetching.
Well, batch fetching, faulting, because when you deal with thousands of...
Don't forget that.
Yes, indeed. Yeah.
Because what you can do with prefetching is sometimes you have like an object model, and you instantiate a version of an object, and then you start using it in UI, and then put on the tracing, and you like executing like 100 queries. But if you do prefetching, it just gets all related stuff with one single join. So it kind of helps to do it at the right moment. Like a lot.
Yeah. True.
Especially have you checked the collection UI collection view controller and UI table view also implements the prefetching protocols now, in which basically you are started to load instead of doing it, for example, on the queue on the you start doing it before now. It works like a charm.
Mm-hmm.
So they are trying to fix a lot of issues because Core Data is one of the oldest frameworks for macOS.
Yeah.
Come from the macOS.
Not from
macOS
macOS,
era.
but from if I'm not mistaken, from Next Step era.
Yeah,
And
exactly. It's
that's why
30 years now.
But also with core data, if you need to choose like a persistence storage stack, the one thing that core data has that no other framework has is that you're guaranteed that Apple will maintain it and that they will
that's
keep it around for a long time, because even the timer app uses core data. It's like every single app that Apple has ever created, you can bet your ass on it as core data.
Yeah, and for instance, such legacy as inheriting a NS managed object from a NS object is also it's a legacy from some previous era. And some, maybe some of you read an article from Dave DeLong, who worked in core data team some years ago, and he said that some Apple engineers tried to abstract NS managed object out of NS object because it should be different entities, but they couldn't manage because of all this legacy, all these decades behind the framework. Yeah, well, we have what we have.